Right, drawing lines, and I'm just going to explain how I go about drawing this line here. Y equals 2x plus 1. Well, the plus 1 tells me where it cuts the y-axis. So if I put a dot at plus 1, that's where it's going to cut the y-axis. Then what I do is in my mind, I remove the axes. And from that dot, I draw a gradient of 2, and 2 can be written as 2 over 1, or in other words, rise 2, run 1. Rise 2, 1, 2, run 1. Now, do I run to the left or do I run to the right? Well, the answer is to the right, because it is a positive slope. In other words, when I join these two dots, that is a positive line. Okay, it also connects through here as well. And once I've done that, I can put the grid back and I can join up the dots. And there we have the straight line. Next I'm going to consider this line down here. Notice it's got a minus, and the gradient is 2, rise 2, run 3. And the y-intercept is this minus 1 down here. So I always start with my y-intercept. It's at minus 1, put a dot. Next step, in my mind, remove the axes. Next step, consider the slope of 2 over 3 but negative. Rise 2, I always start with the rise, 1, 2, and then I have to think, is it to the left or is it to the right? It's to the left, 3, because I want a negative slope. If you're not sure about positive and negative slopes, you need to watch the previous video. I could do another rise 2 and another run 3 and put a plot there, and equally rise 2, in the sense it's go down 2 but it's still a vertical direction, and run 3, and I end up with a straight line. Put the grid back, put the line through the dots, when you show this on your paper, you should put dots where I've put dots. You shouldn't just draw the line in, just in case your line just misses. And in fact, I use crosses as opposed to dots. Okay, I'll show you one more. And that will be the line y equals x over 3. Notice that there isn't plus or minus a number after the number of x's. So in other words, it's going to cut at 0, 0. Put a dot, remove the grid. Now, x over 3. X over 3. X over 3 can be written as a third of x. Or in other words, 1 over 3. Rise 1, run 3. Rise 1. Is it positive or negative? It's positive. So I move to the right. Rise 1, run 3. Coming back this way. Rise 1, run 3. Put the grid back, put the axes back. Put a line through your dots with a ruler. And there we have it. I said one more. I'm going to now do 2 more after my 1 more. Get rid of this one. Right, this one here, y equals 2x. No, y equals minus 2. There's no x. Now that tells me it's a special case. No x's. Now when that happens, we need to go to the spot on the y-axis where y is minus 2. And we say to ourselves, no matter what happens to x, y is always minus 2. That'll be true for every value of x. Put a line through. The other one I wanted to quickly show you is when you see something that starts with x equals, say, a positive number, that's where x is 4. This is the x-axis. It doesn't matter what happens to y, x will be always positive 4. All these dots here. In fact, even dots on here. Oops. It's supposed to be in line. Put a line through.